So today we'll solve one of the problem with respect to the candidate elimination algorithm. So the input instances are here, x1 to x7. The database is related to a car company database. Okay, so the J represents Japan. The model of the car is the Hyundai. The color is blue. It's a 1980 model and it's an economy car, and the instance is positive. X2 is again Japan, Toyota, green 1970, and it's a sports model and it's a negative sample. X3 is Japan, Toyota, blue 1990, an economy car. USA, Chevrolet, red colored 1980 economy. Again Japan, Hyundai, white 1980 economy. Japan, Toyota, green 1980 economy. Japan, Hyundai, red 1990 in economy, which is a negative sample. So these are the given instance samples to us. Okay. So now we have the positive and the negative instances. So as per the discussion with respect to the candidate elimination algorithm, to begin with the problem solving, we first need to initialize, okay, our initializations S0 and G0. So we have initialized S0 to all 5 and G0 to all question mark, right? So when we have a positive sample, we have to perform 2 steps. What are those? So I'll just write that in the left hand side of the space here. So when I get a positive sample, I am going to consider, I'm going to move from the specific to generic. Okay. So I'm only going to deal with the specific term. If I find any difference in the values of the attributes, I will make that as a question mark. So I'm going to generalize it. So when I tell I'm moving from specific to generic, when I get a positive term, I'm going to only handle the specific values of it. In that, if I get any change in the value, I'm going to generalize it. So which means specific to generic. Okay. So when I get a negative value, I'm going to move from generic to specific. Okay, so what do? I'm going to take the generic term. I'll be applying only to the generic term by considering if there is any change in the value observed. I'm going to pull out that generic term. Okay, so it can be any value of the attribute, okay, which is more, where I observe the change, okay, that value, and all the remaining will be question mark. Okay, so which means that moving from generic to specific, generic taking the specific value of it and placing it one, all the others as question mark. So the same thing repeats until if I find any of the values difference in the given test instance. So this is about your candidate elimination algorithm. And one more important step that I have to do is eliminate any inconsistencies present. Let us check out with the example. What is that eliminating instances with G and S? Okay. So since my first is a positive example, okay, so I have x1, right? I'm going to take x1 instance. So s1 is going to be assigned with x1. So S0, G0 is assigned already. I'm going to take the first instance. It's a positive instance. So I'm going to assign it to S1. S1 is the first instance. Okay. So the first instance is given since it's the positive one. And my G1 remains the same, right? I'm not going to touch up the G1 when I get the positive instance. So G1 remains the same. The next instance is x2, which is a negative instance. When I get a negative instance, I'm only going to touch the generic term and not going to touch the specific term. So S2 remains the same. I'm not going to touch the specific term. But whereas the G2 term, okay, since it's a negative term, I have to compare each and every term. So I'm going to compare S1 with X2. So the J, I'm going to compare J with J, it's the same. Again, H and T, I observe a difference over here. So when I observe a difference over here, I'm going to take this particular value from the specific term. Again, I'm not going to touch my instances here, the value of it, but I'm going to consider the instance S1 here. So the S1 value, I am going to pull out the specific value of it and I'm going to write it here. So generic to specific value. Okay, so generic, this term, this particular term, generic to specific value. I'm going to take the value and put it. All the remaining is going to be question mark. Next, I'm going to check the other value. So it is B and G. There's again a difference that is observed. So I'm going to take this blue specific value, put it into the constraint, okay, the instance B, and the rest remaining all as question mark. Generic to specific value. Okay, then 1980 and 1970s, it's again a different one. So I'm going to pull this out and place it into it, all the remaining as question mark. And the final one is again S and E. It's again different. So I'm going to take it and place it into the instance, all the others being question mark. So I have finished this. Is there any differences between, so candidate elimination algorithm, I have to check if there is any contradictory statements. So in the second term it is H, again it is H over here, so there's no contradictory. The third feature value of it is blue and blue, so it is having no contradiction. Again 1980s and 1980s, no contradiction. E and E, there's no contradiction observed between S2 and G2. Let's go to the next instant. So I'm going to take the next instant, which is the positive. And since it's a positive instant, I'm only going to consider the specific term. The generic term remains the same. So I will keep the generic term as the same. Whereas the specific term, I'm going to generalize it. So I'm going to consider S2 is now compared with X3. Okay, so S2 is J and J remains the same. It is okay. But H and T is different. The second term is again different over here. When it is different, I have to replace this H with a question mark. So I'm replacing it with a question mark. Then I have blue. Okay, again it is blue, so it's not a different. Okay, 1980s and 1970s, there's a difference that is observed. Since there's a difference observed, we are going to generalize it with a question mark. So I'm going to generalize it with a question mark over here, and the next E value, E remains the same, so I'm going to keep it as it is. Okay, let me just erase this and continue. So here my candidate elimination, I have to check the elimination factor. See, you can see in S3 and G3, see it is telling, the second term is telling a question mark, but here it is telling no, it wants a specific value as H. Here it is telling I'm generic, I'm open, generic to anything that I get, but here it is telling as H. There's a contradictory statements within this value, so I am going to eliminate it. You can see blue, okay, and the third feature blue remains the same, so I have no issues with that. The first one, you can see J and H, which means that it is okay, it is taking a common value for it, or I'm only considering the values which are being present here with respect to the given instance. So if I consider 1980, there's a question mark over here, so which means that there is again a contradictory statement. My specific term is telling I'm acceptable to something, but here my generic term is telling no, I want it specific to be 1980, which is a contradictory statement here. So I'm going to eliminate this, and the economy remains the same. So after eliminating these two, I'll only be having the blue and the E term with me remaining. Okay. And next, when I go to the next negative instances, when I just continue with the next negative instance over here, okay, so the next negative instance that I would get here, and I will have my S3 and G3 with me. So when I have S3 and G3 with me, so it is UCR 1980 and E. So let me just consider that value here. Okay, so I can compare that with this. So it's going to be, so X4 is going to be UCR 1980 and E. Okay, so X4 is now going to be compared with S3. Okay, it's going to be compared with S3. So let me just scroll a little up. It's going to be compared with S3. Okay, so when I'm going to compare with S3, it's going to tell me the first. Okay, so when I tell it is a positive, it's a negative instance. So when I tell it is a negative instance, I'm going to work with the G. S remains the same, so S4 remains the same as S3. but I'm going to compare it with G4. Now G4, okay, each and every term I'm going to check it out and specify, and the specific value is being considered. So when I take J, okay, and U, the first term is different, okay, so I'm going to pull out the first J term over here and all the remaining is question mark. The second one is already a question mark over here, so I need not consider that. The third one is blue and R, so it is different, so I'm going to take blue separately. Specifically, I'm going to pull out this value from here into the generalization, okay. And then finally you can see 1990s, there's already a question mark, so need not worry. And finally E remains the same, okay. Since here, when I check out the taking the values of it, E remains to be here, so I'm going to add the value of E because B is already being present. The remaining is E, so I'm going to add E to G4. I'm going to check out is there any contradictory statement. So J and J remains the same, B and B is the same, E and E is the same. There's no contradictory statements available here. So my next X5, so I have to compare with X5. So I'm going to scroll a bit down and I'm going to compare it with X5. So my X5 instance is X5 is J H W 1980 and E. Okay, so I have this X5 instance. X5 is a positive instance. When it is a positive instance, I'm going to change my specific term. My generic term remains the same. Okay, so generic term, I'm just going to pull all these contents that I have over here. So generic remains the same, whereas specific is within the specific, I'm going to generalize it if there is a change observed. So I'm going to compare now. J and J remains the same. H is already a question mark. I need not worry. Blue, okay, and the W, there is a change of it. So I'm going to generalize it with the question mark. And 1980 is already it's a question mark, so need not worry. And the final is E. E remains the same. Okay, but with S5 and G5, I have to check out is there any contradictory statement. See, the third column over here is a question mark, but again it is telling the blue. So there's a contradictory statement. It's telling I'm generic for anything that is open, but whereas here it is telling no, I'm only very specific to the blue color. So a contradictory statement, so I'm going to eliminate this, and the remaining J and E remains the same. Okay. Let's consider the x6 instance and the x7 instance. So x6 instance is over here. So I have J, T, G, 1980. Since it's a positive instance, I'm going to preserve my G value the same and my S value is going to change. So S value is going to be compared with each and everything. My S5 value is, let me just write my S5 here for the reference, okay? So my S5 is the same as S6. Okay, so I'm going to compare X6 with S5. So which means that, um, uh, okay, just a second, guys. Let me erase this. I'm sorry. Okay, so let me take my S5 value. So X6 is going to be compared with S5, right? So S5 is going to be J question mark, question mark, question mark and E. Okay, G6 remains the same. I'm not going to touch up that, but S6 is, now I have to compare S5 with X6. Okay, so when I'm going to compare with that, here you can observe that J and J remains the same. Already there's a question mark, there's a change in the value, I need not worry. There's already a question mark, need not worry, question mark and E. So which means that S5 remains as same as S6. Okay, so is there any contradictory statements here? J and J is the same, E and E is the same. So there's no contradictory, I need not worry. Finally, I have to compare X7. It's a negative term. So when I tell negative term, the specific remains the same. So it is compared, it remains the same. Whereas my generic term has been changed. So when I take the generic term of it, I'm going to compare X7 with S6. Okay. J and J, all the remaining are question marks. So I need not worry. And the remaining E is also the same. So I will get the same as what I got with G6. So G6 remains the same as S6. This is what about your candidate elimination algorithm. The very main important thing that you have to note is when I have a positive instance, I'm going to move from generic to specific, where I only consider the specific term and try to generalize it with a question mark. When I consider a negative term, I'm going to move from if I am not wrong, if I'll just write it over here for you. So when I get a positive term, as I told you, I'm going to move from specific to generic, and in that I'm only going to consider the specific term. Okay, and I'm going to generalize it if I find any difference in the attribute values. Okay, this is what the positive. If I have the negative term for it, okay, I'm going to move from the generic to specific, where I only preserve the where I only change the generic value of it. The specific value remains the same, and in the generic I'm going to take that specific value from this S. Okay, from S, not the X. I'm not going taking the input instances, but I take the value from S. So I take that value and specify it, and all the remaining becomes the question mark. So I'm going to generalize generic to take that particular specific value and place it over here. So generic to specific. Okay, so this is about your candidate elimination algorithm. If there is any contradictory statement, so in the generic, if there is anything value with respect to example here, if there is any value with H and there is a question mark over here, specific term is telling I'm okay for anything, but whereas here it is telling that he is very very particular that he wants the car with respect to the Hyundai. So it is contradictory statements. And one more thing here is we need not worry about the opposite term over here, because anyways we are already having a generic value of it, so this need not be considered. Only this term has to be considered in our model. Okay, so I hope I've made this clear. The example is clear. I think I'll stop the recording. Thank you so much. See you in the next class.